Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the October-November 2023 Cambridge 9709 Pure Mathematics P1 paper, and this is variant 3. This is paper 1-3, and this question here is about series. It says the first, second, and third terms of a geometric progression are 2p plus 6, 5p, and 8p plus 2 respectively. Find the possible values of the constant p. Okay, and there's a few ways you could go about this question, but I personally think the simplest way is to just first of all understand that first we have a geometric progression, a geometric series basically, and these are 3 consecutive terms, the first 3 terms, the first term, second term, third term. And we know that a geometric progression is such that to get to from one term to the other, you multiply by what's called the common ratio. And the common ratio, okay, so for example, this is the first term, let's call it U1, the second term, U2, the third term, U3. The common ratio would be given by taking a term, like the second term, dividing it by the first term, and it's also given by taking the third term and dividing it by the second term. A term divided by the previous term will give you a constant ratio each time. Okay, so using this concept here, we can set up an equation. We can say that 5p divided by 2p plus 6 will give us the same ratio as 8p plus 2 divided by 5p. Okay, so we have these terms, and this is an equation now which links these two, these together, these common ratios, and we can then basically solve this by cross multiplication and end up with a quadratic equation. So if we do simplify this now, I'm going to multiply both sides by 5p, so I'm going to get 5p times 5p, which is 25p squared, and on this side I'll have 8p plus 2 multiplied by 2p plus 6. That should lead us to a quadratic equation, and then, as you can see, there's going to be some possible values of the constant p, so we'll be able to solve for those values. So it looks like we have to do some factorizing in the end. So if we expand this, you have 8p times 2p, which is 16p squared, and you have 6 8s are 48, so plus 48p, plus 2 times 2, which is 4, plus 4p, and plus 12. Now, when we have a quadratic equation, I want to solve this by factorizing. We use the zero product property, so we have to make sure that it says equals 0, so everything must be brought onto one side. Let's subtract 16p squared from both sides. So 25p minus 16p squared is 9p squared. And then we're going to have 48 plus 4, which is 52p. Subtract it from both sides, you have minus 52p. And you have 12, take away from both sides, you get negative 12 equals 0. All right, so we have this equation that we want to solve. Let's first see, is there any common factor that we can use to simplify it? 3 goes into 9, 3 times 3 goes into 52, 3 goes into, no, it doesn't go into 52, does it? So no, there's no common factor that we can use to simplify this, so we have to factorize it as it is. So let's see if we can factorize it in a way that we don't need to use a formula. I mean, somebody might end up using the formula here because the numbers look a bit more complicated, but I'm going to try to split the middle term in my own little visual fashion that I like to use. So I'm going to put my little window kind of shape, and on the top left I'll write the squared term, so 9p squared. On the bottom right I'll write the constant term, which is minus 12. And then I'm going to find two numbers that when you multiply them together, you end up with the same as these two multiplied together. So the product has to be negative 9 times 12, which is 108 p squared. And the sum of those two terms, the sum of these two terms that I'm going to have here, must be negative 52. Okay, so it's 108, not 180. Why did I put 180? I meant to put 108. Okay, so negative 108p squared and negative 52 is going to be the two numbers that we're looking for. So if we think about that, then multiply to give us 108. I think 54 times 2 will work, won't it? That gives you 108. Yeah, so you're going to have minus 54 and plus 2. So I'm going to put minus 54p and plus 2p. That will give me a product of minus 108, and it will give me a sum of negative 52. That's correct. Okay, good. Now I'm going to look at these two terms and write the common factor out here, which is actually 9p. 9p goes into both of those. And then I can say, okay, 9p times 1p gives me 9p squared, and 9p times negative 6 gives me negative 54p, and p times plus 2 gives me 2p. So we can see that these are our two factors. We have p minus 6 times 9p plus 2 equals 0. We can check it. 9p squared plus 2p minus 54p, that's minus 52p, and minus 12, so it works. Okay, so these are the two factors. So now we can say that if p minus 6 is 0, that means p equals 6. And if 9p plus 2 equals 0, then 9p equals negative 2. So p equals negative 2 over 9. So these are the two solutions to our equation. And that's part A done. All right, now for part B, it says one of the values of p found in A is a negative fraction. Use this value of p to find the sum of infinity, or the sum to infinity of this progression. All right, so we're going to use p equals negative 2 over 9. Now the sum to infinity only exists when the magnitude of the common ratio is going to be a fraction. Okay, so obviously that should be the value of r should give us a fraction less than 1. Its magnitude should be less than 1. So obviously that will give us that, but we'll see. The sum to infinity is given by a, which is the first term, over 1 minus r. Now this formula is in your formula sheet. That you'll find this in the formula sheet, the sum to infinity. So that's something that you will realize from that. So now, in order to find the sum to infinity, we need to find the first term, and we need to find the common ratio. Those are the things we need. Okay, so if we go back to the original question, the first term is 2p plus 6. So we know that the first term is 2p plus 6. Okay, A and U1 both mean this is the first term. So we know p is minus 2 over 9. So we can say the first term is going to be 2 times minus 2 over 9 plus 6, which is minus 4 over 9 plus 6. Let's write this as a single fraction. That's going to be, if you make the denominators the same, you have minus 4 over 9 plus, and that's going to be 54 over 9. So you're going to get 50 over 9. So the first term is 50 over 9. I'll leave it in this form. And then we need to find the common ratio. And we already mentioned the common ratio could be given by these two. As we already found what 2p plus 6 is, I'll use this form. I'll say it's going to be u2 over u1. Okay, so the common ratio is the second term divided by the first term, which was basically 5p over 2p plus 6. 5p over 2p plus 6, which is 5 times minus 2 over 9. Okay, over 2p plus 6, which you already found, which was 50 over 9. So you end up with minus 10 over 9 divided by 50 over 9, which you can take as minus 10 over 9 multiplied by 9 over 50. So you end up with the common ratio being negative 1 over 5. So we know that the first term is 50 over 9, and the common ratio is minus 1/5. As we can see, that this will give us sum to infinity because the common ratio has got a magnitude less than 1. So the sum to infinity, therefore, is going to be a over 1 minus r, which is 50 over 9 divided by 1 minus 1/5. So that's 50 over 9 divided by, and that's going to be 1 plus 1/5, which is going to be 6 over 5. Okay, so you have 50 over 9 times 5 over 6, which gives you, does anything go into this? That gives you 3, and that gives you 25. So 25 times 5, which is 125, over 9 times 2, which is 27. So we can say that the sum to infinity, therefore, is 125 over 127 over 27. Sorry. We can leave it like that if we want to. or we can write it to 3SF. You can say 125 over 27. That gives us 4.63 if you want. Okay, 4.63. Both of those are fine. I personally leave it in this form. That's also acceptable. Unless it says exact value, it doesn't. All right, so that's fine. Okay, so there we have the sum to infinity of this geometric progression. And they only exist, sum to infinity only exists when you have a negative common ratio, which we do, as we've worked it out. Okay, so there's the answer to number 5. Not too difficult. Other questions from this particular paper can be found in the playlist. It will be linked over here. Other questions about series from P1 of Edexcel can be found in the playlist over here. You'll find questions to do with series in Edexcel, also from P2 of Edexcel, but some of the questions might be outside of our syllabus here. Things like recurrence, relationships and stuff are not in the Cambridge syllabus, so I'll put the link here, but you might find that some things are not relevant. Most of them will be the same, and you can then also subscribe to my channel by clicking on this link. Thank you for watching. See you soon.